Hey, so in this video, I'm going to go over how you can solve any equation or any single variable equation using the TI84 or TI83 graphing calculator. I'm going to be using a TI84 plus CE, but I'm actually going to be doing a little bit of stuff on the TI83 today as well. These things are basically the same thing, except for a few small differences that I'm going to go over today. I also have another video where I go over some of the basics with these calculators, so feel free to check that out on my YouTube page. And yeah, let's get into it. So the idea with solving equations using these graphing calculators, you're going to want to use the graph function here, which you just go to the y equals screen, and then we eventually put in some functions and then hit the graph button. But just to kind of set things up, what we're going to do in that screen is we're going to set the left side of the equation as y1 and the right side of the equation as y2. So that's what we're going to put into the y equals screen in the calculator. And the idea is we're going to see where they intersect. The x value of their intersection point will be the answer to this equation. And this will work with any single variable equation as well. Just keep in mind, sometimes you might have more than one solution. I'll get into that later on in the video. So let's set this up. Okay, so the left side of our equation is 2 to the power of x minus 1, and then separately minus 3. So this is where we're going to see our first difference with the two calculators. This is actually going to be the main difference that I highlight in this video, but you're going to want to start by writing base 2, so just a 2 in the y equals screen, or on y1, there we go, it's early. And you hit this up arrow to create an exponent. Now, if yours doesn't do the little flashy box thing, that's okay, I'll talk about that in a second. But we're just going to put in our variable x, that's this button here, I talked about that in the last video as well, minus 1. Now to get out of the exponent, because notice how the minus 3 is not included in the exponent, you're going to want to hit the right arrow, and now you can see the little blinky is out of the exponent, and we can enter in minus 3. So I'm just going to pause for a sec here. If we go over to the TI83 graphing calculator, and some of the TI84s do this as well. I was just testing this out. When you put in your base and then you hit the exponent button, you don't get the little blinky exponent like we did on the last one. Here, I'll show you again on the TI84. So you hit that and then it creates a little exponent box. This one just has the up arrow. So if you're going to input multiple things like that, you need to isolate the exponent. You need to isolate the stuff that's in the exponent. So I'm going to create a bracket, put the x minus 1, and then close the bracket. That is telling the calculator, hey, just that bit is the exponent, and now we can input the rest of the function. This should work just fine, but you really need to tell the calculator what to do. And even if you're worried about this, you can even put the whole thing in brackets. Get the base in there, create a new one for the exponent as well. You can't really have too many brackets as long as you're closing them and you're being careful. And of course, if you know what you're doing, I use brackets all the time. If you're ever unsure if your input's going to come out kind of weird, then you should just use brackets. It's always a safe measure. Anyways, well, let's go back to the TI84. There we go. Okay, so we still need to put in the right side of our equation into y2. So we first have negative, and then we're going to create a root. So to get a root, you need to go second and then the x squared symbol. That will create a root. Now, again, the TI83s, they might just open a bracket for the root. So just make sure you close a bracket if that happens. X plus 3. And like the exponent, if you want to get out of the root, you just hit the right arrow. And now the blinky is out of the root, and we can enter plus 8. So I don't know what my Windows setting looks like right now. It looks like it's just normal 10 and 10. When I hit the graph button, we'll see both graphs, and we will be able to see a clear intersection point right there. And I know because of the nature of these two functions, there's only going to be one intersection point. But again, I'll get into that later of when we might see more than one. Okay, so if you really want to zoom in on your intersection point, also if you can't see your intersection point, you'll definitely want to adjust your window. So since everything's going on in quadrant 1, I think I'm just going to isolate quadrant 1 here. So maybe I'll bring my x min to -1 and my y min to -1. I usually like to use -1 so I can still see the axes. Because if you just go to 0, you might not be able to see the axes, especially on the calculators that aren't in color or have a backlit or whatever. So I can clearly see the intersection point. So now if you want to get that intersection point, you're going to go to the calc menu, so second trace, and you're going to select option 5, which is intersect. Now, in cases where there's multiple intersection points, you will want to get really close to the intersection point using the arrow keys there. It'll first cling on to one of the curves. It should be Y1. And once you're nice and close to the intersection point, just hit the enter button. Same thing with the other curve. You'll want to get nice and close to the intersection and hit enter. It'll say the word guess for some reason. I still haven't figured that out. Just hit enter one more time, and then it will hone in on the intersection point. The one we have there, we're only concerned with the x value, is 4.0605373. Now, I always recommend using all of the decimals and just being as exact as you can be, especially when you're checking your answer, unless the question tells you to round, of course. But I'm going to intentionally just round to a few decimal places, and I'll explain why. I'm just hoping to show you something by doing this. Let's just go to the nearest thousandth. Let's just do that, 4.06. So, and the y value, not really too important in this type of question. However, you're going to see that number 5.34 is actually going to come up in a second here because I'm going to check my answer. And of course, if you're asked to solve a question algebraically, this method, it's not going to help you get to that solution, but it's a good way to check your answer. And if you have like a multiple choice question, this is just an easy way around having to do a lot of work. So I'm going to go back to the main menu by going second quit, and I'm going to substitute that x value into both equations, or both sides of the equation, I should say. If they're equal, that will tell us that this is the correct answer. So 2 to the power of 4.061 minus 1, let's get out of the exponent, minus 3. And hey, there's that number again, 5.34, and it looks a little bit different, but that's because we rounded. Okay, so if we rounded, that number is going to come out a little bit different, but the main idea is there. Same thing with the other side, let's plug it in. So negative root 4.061 plus 3, get out of the root, plus 8. I almost hit graph, sorry, I didn't want to hit enter. And you can see they're almost the same. Now, the reason why they're a little tiny bit off is because we rounded. If you round your answer on the graph screen, then when you're checking your answer, your decimal places will be a little bit off. That being said, these are definitely close enough that I can say, yeah, this is the right answer. So there you go. Now, I'm going to just sneak in a few extra things into this video as well. The first thing is just keep in mind we might have more than one intersection point. So I'm just going to start by resetting my window. So zoom, and you're going to select option 6, which is standard. And I'm just going to put in a quadratic that has a like a low y-intercept, and then I'll just do a straight line. That's a pretty good example. Let's say we have an equation that's like x equals x squared minus 9. It will look something like this. Or I shouldn't say it looks something like that. It'll look exactly like that. And you can see this is a case where we have two intersection points. So the equation x squared minus 9 equals x has two solutions. And we can get these solutions graphically by doing the same thing. But just keep in mind, if you're going to use the intersect function, you'll want to get nice and close to that first solution. There you go, negative 2.54. And then if you want the other one, you're going to need to go to intersect again and get really, really close to that intersection point, because you need to tell the calculator which intersection point you're concerned with. This one here is 3.54. So there you go. And I got one last thing for this video, just to emphasize the importance of brackets. Let's say you want to input the graph of something rational like 1 over 2x. This is a really good example with these graphing calculators. So if you know how rational functions work, this guy should have a vertical asymptote at x equals 0, because we're not allowed to have an x value of 0 because it would result in a scenario where we would be dividing by 0, which just goes against the rules of math. Now, if I just put this in straight up, I get this. So 1 divided by 2x, right? Shouldn't have any problems there. Well, if I graph that, you can clearly see there's no vertical asymptote at x equals 0, where there should be. Even if you think it might be there, and it just, well, I mean, this doesn't look anything like a rational function. Rational functions do a little swoopy thing. This is a straight line. That tells us we did something wrong. Because right now, what the calculator is thinking, let's get rid of the blinky there, it's thinking 1 divided by 2 times x. So it's basically thinking that, 0.5x, which is the equation of a straight line. We should know that. It's a straight line with the slope of 1 over 2. That's the same thing we had before there. So if you want to create a rational function, if you want to make sure that x is in the denominator of that, you need to first hit 1 divided by, and then you create a bracket just to make sure that the 2x is in the denominator. You need to tell the calculator, hey, just that bit is in the denominator, and that's where the brackets come into play. And if you graph this, you can see, there you go. We clearly have a vertical asymptote. And if you're not totally sure about that, let's just zoom in a little bit. Maybe we'll go like -3. I know you can use the zoom in buttons. I'm not really a huge fan of using those. I like to do things manually. Clearly there's a vertical asymptote there. Clearly this is the proper graph for 1 over 2x. So anyways, yeah, I hope you learned something new today, and thanks for watching.